Okay, folks, welcome to our next lecture of Unit 5, and today we'll be talking about average atomic mass. Now, we already have an idea from our previous lectures that atomic mass is the sum of the protons and the neutrons, but what I want to look at here has to do with the atomic masses that are listed on the periodic table. Each element has its own atomic mass, but the numbers that you're seeing there are a little different than what you see and when you use to calculate the mass of an atom. So when we're looking to see the number that we have there, first of all, it's an average mass compared to that of the carbon-12 atom, which was assigned an exact mass of 12.00 AMU. So the values that we're getting for that are relative. Now, the other thing we have to consider with average atomic mass that we didn't consider before is that we have to look at all of the isotopes, all of the variations of that element based on their numbers of neutrons and their abundance percentage. And their abundance percentage is an expression of how much of that element exists in nature. And we use those things, all right, to calculate our atomic mass, and that's why you'll notice that the masses on your periodic table for the most part are not considered whole numbers. So there are a few that are whole numbers, and they have to do with radioactive elements and elements that don't exist very long, so they're giving you the most stable form. So let's take a look here on how we find things dealing with atomic mass. Now, the way that we calculate atomic mass is we need a few things. Well, the first thing we need to know is what is the percent abundance of isotopes, and that's a given value. That would be something that you could look up in the literature, and you need to know the mass of each isotope of that element. Now, how many isotopes there are depends on the element. Some have 2, some have 3, some may have more. So you have to know what the masses of each of those are going to be. And when we take those two values, we calculate what's called a weighted average. And you'll notice here that in our notes that we're looking at the mass of isotope 1, the mass of isotope 2, and so on. So this can be as many isotopes as we need, but the important thing here is not only are we expressing the mass of the isotope, but we also want to express that percent abundance as a decimal, and we can essentially just do that by moving the decimal over 2 spots to the left. So why don't we look at an example here on how we calculate atomic mass. Oh, it's that favorite time of the notes. I know this is a short one today, folks, so we're going to take a little bitty brain break here. Maybe we'll just move our toes and move our fingers to get the blood flowing. So today's Chuck Norris fact of the day for you history buffs. As President Roosevelt said, we have nothing to fear but fear itself. And Chuck Norris. Make sure you tell your social studies teacher that one. Alright, so here's our example of how we calculate average atomic mass. And the example we're going to be using here is going to be magnesium. Now, magnesium exists as 3 different isotopes. Magnesium 24, 25, and 26. And over on the right-hand side are our examples on a percent abundance. So 78.7% of all magnesium exists as magnesium 24, 10.13% exists as magnesium 25, and 11.17% exists as magnesium 26. So essentially all we need to do here is first get our abundance expressed in terms of a decimal. So we're going to move our decimal 2 spaces to the left, 1, 2 over here, 2 spaces and 2 spaces. And now we're just going to multiply each of these by the mass of that particular isotope. So for the example here, we're going to do first is magnesium 24. So I'm going to take my mass of 24. I'm going to multiply by 0.7870, and that's going to give me a mass of 18.88. All right, and that's how much contributes by magnesium 24. Now, we want to conserve our significant figures, so we're going to look at this as being 18.9. If I was to do my calculations for the other two, I would do them in the same manner. And for magnesium 25, 25 times 0.1013 is going to give me 2.53, and the last one I will get here, 26 times 0.1117, that's going to give me 2.90. And if all I need to do now is each of these contribute to that atomic mass, all I have to do now is add these up, and that will give me a weighted average of 24.3 AMUs. All right, and we're conserving our significant figures here. And again, if you take a look on your periodic table, you will see that is the average mass, or that is the mass that's listed for magnesium. And this works for any of those sort of elements that we have. As long as you know what the isotopes are and you know their percentages, it's pretty easy to calculate. So if there are any questions, please make sure you ask. Refer back to some of the previous notes from before and use those to help you calculate what your atomic mass is going to be.